Welcome. This is section 4.3, multiplying radicals. So the first thing we're going to do is we're going to look at some properties of radicals that we have already talked about, but it might be helpful to see the math notation for those properties. Okay? Assuming that A and B, so I'm going to start reading right here. Assuming that A and B represent non-negative, which means not negative, so these properties don't work well when A and B are negative numbers. So if A and B are not negative, we have these properties. So we've got 1, 2, 3, 4. We've got 4 here on this row that we're going to talk about. Actually, we're not going to talk about the last one because I don't think we have to do with radicals that have fractions. And we have 4 more down here because the same properties that we have for square roots work for index n. So let's talk about the first ones. If I have the square root of 25, for instance, 25 is 5 squared. Square root undoes the square, so the answer there would be 5. If I had the square root of, let's say, 7, and I squared that, square root of 7 is the number that I have to multiply with itself to get 7, so I'm going to get 7 out of that. Okay, next property, and I think I'll write this one up above because I'm running out of space below, so I'm going to write this one up above. If I have square root of, let's say, 25 times 36, let's do a big number. 25 times 36 is big. What I can do is I can make that a square root of 25 times the square root of 36, which is 5 times 6, which is 30. But we can also use the property in reverse. If I have a square root times a square root, I can make that 1 square root by multiplying the radicands. So we'll use it a lot that way today. Okay, same properties are valid if we have index n. Let's write a couple of examples. If I have the 5th root, so index is 5, there's the index right there. If I have a 5th root, so a radical of index 5, of something like 7 to the 5th power, the 5th root and the 5th power undo each other. They're inverse operations, so I get 7. Okay, if I have something like the 6th root of 3, and I raise that to the 6th power, 6th root and 6th power undo each other, so I get 3. Okay, next property. If I have the cube root, we're going to work it the opposite direction. If I have the cube root of 2 times the cube root of 4, the rule says I can make that the cube root of 2 times 4, in other words, the cube root of 8. Well, now think about 8. 8 is 2 times 2 times 2, so the cube root of 8 is 2. So we can use these properties to help us with simplifying radical expressions. Okay, now there's a special note here that I want you to look at. What we had up above said A and B are not negative. So if we try to do these same things with square roots of negatives, it doesn't always work. So what we're going to remember is when you're working with radicals, so it doesn't actually work. That's not equal. It does not work. When you're working with radicals that involve square roots of negatives, you're going to first rewrite them in terms of I. You're going to bring the negative out as an I. We'll see that as we get into some examples. All right. We might also need the distributive property. We're going to see that in a little bit. So let's jump into the examples. So let's do example 1. We have the square let's read the instructions. Multiply and simplify each of the following. So our final answer should be simplified, but we're multiplying. So you notice that's a multiplication symbol right there? We're multiplying. So square root of 10 times the square root of 6. The rule up above said I can do 10 times 6, which is 60, and make that a single square root. So then we're going to take the 60. I know there's a pair of 2's in there because the 10 has a 2 and so does the 6. So I'm going to take the 60, break it down as 2 times 30, and then the 30 is 2 times 15, and the 15 is 3 times 5, and then 5 is a prime. So what I have is I have a pair of 2's that are going to come out as a 2, because remember, square roots undo squares. 2 times 2 is a square. 2 comes out. 3 times 5 stays underneath. I'll write that as a 15 and we're done. Okay. Square root of 13 to the second power. Square root of 13 squared. Square root and square undo each other. My answer is 13. That's our property up above. Right here. Okay, it's that property right there. Square root and the square undo each other. So we get 13 out of that one. Okay, let's do our next example, example 3. Now this one's a little different because I have a 5 in there. So I can't just do 5 times 3. That doesn't work because I'm squaring the 5 as well. Remember what I have? 5 square root 3 times 5 square root 3. So the 5 times the 5 is going to be a 25. And you can switch the order of these guys if you want. And then the square root 3 times the square root 3 is going to be a 3. So I have 25 times 3, which is, 75. Square root 3 times square root 3 is 3. Square root 36 times square root 36 is 36. Notice that's 6 times 6. But we want to get comfortable with the idea that when I do a square root and multiply it times itself, square root of a times the square root of a is going to equal a when a is not negative. Okay? So square root 36 times square root 36 is 36. All right, next example that we're going to do. We have cube roots this time. Notice what we have. Cube roots. We got cube roots. So we're going to take, let's see. Can I switch the order a little bit? Notice that 7, I'm going to pull it out to the front. Then I have the cube root of 2x times the cube root of 4x squared. Okay, there's that 8 that we saw a little while ago. 2 times 4 is 8. Indexes are the same. They're both index 3. So I can make that the cube root of 2 times 4, which is 8, and then x times x squared, which is x cubed. So notice what my 8 is. My 8 is 2 cubed. And both the 2 and the x are going to come out because they're triples. They're cubes. Cube roots undo cubes. So I have 7 times 2 is 14, and x. Everybody came out from under the radical, so the radical is gone. We have 14x. Okay, example 6. First thing I'm going to do when I'm working with radicals that have negatives under them, those negatives are going to come out. Notice that's multiplication. So the negative is going to come out as an I. So I'm going to have I times the square root of 4. And for the second one, negative comes out as an I. I have I times the square root of 9. Okay, square root of 4 is 2. Square root of 9 is 3. So I have 2 times 3. And then I times I is I to the second power. Now think about this. 2 times 3 is 6. I squared is negative 1. Do we remember that? I squared equals negative 1. We're going to use that when we're working with imaginary numbers. So my final answer for this one, negative 6. Done. Okay, I'm going to flip to the next page. All right, example 7. We have a multiplication. See these parentheses right here? We're multiplying 3 times the square root of 2. So we've got this term multiplying with everything inside the parentheses. Oops. Everything inside the parentheses. So what I want you to think about is this is like doing A times B minus C. I need to distribute. So I'm going to do 3 times the square root of 2, multiplying with 2, minus 3 times the square root of 2 times my 4 square roots of 2. Okay, so 3 times 2 is 6, so I have 6 times the square root of 2. And then right here, I have 3 times 4 is 12. And square root 2 times square root 2, that's 2. So what I have is, for my final answer, 6 times the square root of 2 minus 24. Or if you want, if it's helpful, you can write it as negative 24 plus 6 times the square root of 2. Either way is fine. All right, example 8. We have what looks like a binomial squared. Look, this looks like x plus, let's just throw something in there, x plus 3 squared. See that plus sign in the middle? We have to remember that when we're doing something like this, whether it has radicals in it or polynomials in it, it's radical expression or a polynomial expression, we need to multiply that thing with itself. Okay? So what I'm going to do is I'm going to use the box method. You can use the distributive property. If you like the distributive property, use it. Or you can use the box. I'm going to use the box. I'll remind you how this goes. So we're going to set it up to do multiplication. So we're multiplying 5 plus the square root of 7 with another 5 plus the square root of 7. And we're creating a multiplication table. So we're going to do 5 times 5, which is 25. We're going to do 5 times the square root of 7. We're going to do another 5 times the square root of 7. Okay, and finally, we're going to do square root 7 times square root 7, but that's 7. And then we're going to add things together. We're going to add the like terms. And if you use the distributing method, you will get the same thing. So we're going to add all 4 of the terms that are inside the box, all 4 of these. This one, that one, that one, and that one. We're now adding them, not multiplying. We're now at the addition step. So 25 plus 7 is 32. And then 5 square root of 7 plus 5 square root of 7, that's like doing 5x plus 5x and getting 10x, but I don't have x's, I have square root 7s. So there is our answer. Okay, and like I said, if you use the distributing, you'd get the same thing. 5 times 5 is 25, plus 5 square root of 7, plus another 5 square root of 7, plus a 7, and you will get the same thing. All right, let's do the last one. Do you want to use the box? Do you want to use the distributing method? I don't care which. I think I'm going to use the distributing method this time, but you're welcome to use the box. So I'm going to multiply 2 square roots of 5 with 2 square roots of 5. Okay, so that equals 2 square root of 5 times 2 square root of 5. And then I'm going to add 2 square root of 5 times the square root of 7. And then I'm going to subtract. Notice this is a negative times a positive. So we've got negative square root 7 times 2 square root 5. And finally, my last one, negative square root 7 times positive square root 7. Negative times positive is a negative, and square root 7 times square root 7. I could make that the square root of 49, or I can just make it a 7 right away. Okay, now I want you to notice something that's going to happen here. This is really cool what happens here. But let's write down our answer here. So we've got 2 times 2 is 4, square root 5 times square root 5. So the 2 times the 2 is a 4, and then the square root 5 times the square root of 5 is a 5. So I have 4 times 5 is 20. I have a plus 2 radical 35, because that square root times that square root is the square root of 35. But then I have a minus the same thing. So those two are going to cancel out or zero out, and they will be gone. Poof, they'll disappear, right? They zero out, so they're gone. So my final answer is going to be 20 take away 7, which is 13, and we are done. And you would get the same thing if you used the box, as long as you did your multiplication correctly in the box. And that is multiplying radicals.